Welcome to this video on a very important and slightly tricky concept in machine learning, VC dimension and learnability. In this session, I will explain these ideas using simple language and easy to understand examples. We will also look at how something called ensemble learning plays a role in making learning more effective. Let's get started. In this video, we will break the topic into 4 parts. First, I will explain what is VC dimension. This helps us understand the power or capacity of a learning model. Second, we will talk about PAC learning. This shows us whether a model can learn from a limited amount of data. Then, we will understand how VC and PAC are related. And finally, I will introduce you to ensemble learning, a powerful approach that improves how well models learn. Don't worry, everything will be in simple words. What is VC dimension? Let's begin with VC dimension. VC stands for Papnik-Chervonen case, named after 2 researchers. The VC dimension is a way to measure the capacity of a machine learning model. In very simple terms, it tells us how flexible a model is or how many different kinds of patterns it can handle. The more complex model is, the more it can adjust to various situations. That's what VC dimension is all about, measuring this complexity. Now, an important word related to VC dimension is shattering. If a model can correctly separate or classify all possible combinations of a set of points, we say it can shatter those points. For example, if you give it 3 data points and it can correctly handle every possible way of labeling them as 0 or 1, we say it shatters 3 points. The largest number of points it can shatter, that's the VC dimension. So, a VC of 3 means it can shatter any set of 3 points, but not necessarily 4 points. To make this even simpler, let's use an everyday example. Think about your wardrobe. The more shirts, pants, and accessories you have, the more outfits you can create. A big wardrobe gives you more flexibility to dress for any occasion. In the same way, a model with a high VC dimension has more flexibility to handle various types of data. But just like having too many outfit choices can become confusing, a very high VC dimension can also cause problems, which we will talk about next. Now, let's talk about PAC learnability. PAC stands for probably approximately correct. This concept helps us understand whether a model can learn well from data, even if we don't have too much data. A learning algorithm is called PAC learnable if it can find a good enough solution with high probability after seeing only a reasonable number of examples. In short, we want our model to be probably right and approximately accurate most of the time. If that's possible, then the model is a PAC learnable. So, how are VC dimension and PAC learnability connected? The key idea is this: if a model has a finite VC dimension, meaning not too high, then it is a PAC learnable. That means we can trust the model to learn well with enough examples. But if the VC dimension is too high, the model might learn the training data too well and not perform well on new data. That's called overfitting. On the other hand, if the VC dimension is too low, the model might be too simple to understand the patterns. That's underfitting. So, we need to find a balance, a sweet spot, where the model is complex enough to learn but not too complex to fail. What is ensemble learning? Now that we understand VC and PAC, let's move on to something called ensemble learning. This is a powerful technique in machine learning where we combine multiple simple models to create one strong model. You can think of it like this: instead of asking one person for advice, you ask a group of people and take their combined opinion. This group decision is often better than one person's guess. In the same way, combining weak models can give us stronger results. Common types of ensemble. There are three main types of ensemble methods. The first is bagging. It builds several models in parallel using different subsets of the data. Random forest is a popular example of this. The second is boosting. The boosting builds models one after another. Each new model tries to fix the mistakes of the previous ones. AdaBoost is a common boosting method. The third is stacking. It combines the outputs of several models and passes them to another model to make the final prediction. All of these techniques help improve the overall performance of machine learning. How ensemble help learnability? So, how does ensemble learning help with learnability? It does this in two big ways. First, it reduces bias, meaning the model becomes more flexible and less likely to make simple mistakes. Second, it reduces variance, meaning the model becomes more stable and less likely to change completely when given different data. When used carefully, ensemble methods can also increase the effective capacity or VC dimension of the model, but in a smart and controlled way. This helps the model learn better without overfitting. So, coming to the summary, let's quickly go over what we learned today. VC dimension tells us how powerful or flexible a model is. PAC learnability tells us if a model can learn well from data. If the VC dimension is finite, the model is probably PAC learnable. But we must avoid both overfitting and underfitting by choosing the right VC. Finally, ensemble learning combines multiple weak models into one strong model and improves both accuracy and learnability. I hope this explanation made this concept clearer for you. Thank you so much for watching this video. If you found it helpful, please give it a like, leave a comment with your thoughts or questions, and subscribe to the channel for more videos like this. Until then, keep learning, stay curious, and I will see you in the next video.